Okay. Thank you all. This is a talk. It's going to be a very simple talk on R and Hadoop. Hadoop itself is a fairly complex topic, but our focus is going to be how do we really do Mapreduce programming with R and Hadoop. Hadoop is basically, you can visualize it as a kind of parallel processing mechanism framework along with a distributed file system. The distributed file system is what's called HDFS or Hadoop Distributed File System, HDFS. We will keep referring to this HDFS over and over again through this presentation. You got to remember something. This is a batch framework. In other words, it's not really meant for real-time kind of response. The latency in the case of Hadoop jobs typically is very high. So typical query would take anywhere between the minutes to hours actually for Hadoop, depending on how big your storage is. So Hadoop is really not meant for any real-time framework. It's really not a real-time framework. It's a batch framework. That's very important for you to understand. That's one of the reasons actually Google recently, not recently, in 2010, moved away from Hadoop like Google file system to their next generation of processing framework called Caffeine. Okay. However, Yahoo and all still continue with Hadoop, and as I said in this slide, Facebook is one of the largest users of Hadoop with over 100 petabytes of data in Hadoop clusters. Okay. Hadoop is essentially runs on it's Java based framework. It runs on Unix and Linux for development and production. You can use Windows and Mac as a development platform, but typically for production you would need a Unix or Linux machines. Okay. My own presentation demo here is running on Ubuntu here. I'm not going to go through the installation aspects of Hadoop. You can really go through Cloudera site, which is given in the reference, and you can install it fairly easily. Also, Cloudera guys have got a virtual machine. You can really download the VM image and run within your VM. Whatever examples we do here, you could really practice it at home. Mine is really home-based two-machine configuration in my basement. One I'm going to call it desktop. Other one I call it XPS. So you'll be seeing these two screens as we go through this demo side of it. There'll be two screens of one on the XPS side, other is on the desktop side, and I'll be running these demos on a two cluster framework, which is something you could set up at your home and your basement. So that's the idea. I want to keep this presentation very simple so that you can follow the core concepts easily, and that's the idea behind all this. And also I will ensure that it's really gets completed within an hour time so that you all get the benefit of understanding Hadoop pretty well in simplistic terms. The overview of Hadoop, you can imagine like this is the core idea. That is, you are moving computation closer to data. That's very central to Hadoop. Hadoop really ensures that the data stays in your local nodes and you really move the computing closer to data. That's one of the important aspects of Hadoop. And then you do the computing in parallel across several nodes. Nodes are basically any kind of process thread that's running. So for our purpose here, we will assume the two machines I have, which I'm going to demonstrate, are two nodes. Okay, node necessarily does not have to be a computing machine. It can well be a thread running under a computer. Okay, so the large amount of input data, we are really trying to move closer to these nodes. So each of these nodes will have their own storage, and the important aspect of this HDFS or Hadoop distributed file system is when you really copy the data, and there is something called a name node, which is a master. This master treats the whole data and distributes it across several nodes, but then gives you the illusion that you are really dealing with one large file, even though the file is really broke up into chunks and it's all kept in various nodes. Okay. So when you copy the data, each node gets a slice of the input. Now, then what happens is the parallel computing paradigm within Hadoop is called the Mapreduce. Mapreduce, it works like this. Each of these nodes has got several input slices, and then there is a mapping process run on each of these nodes, and it transforms this data, local data, into some other intermediate data, again now kept on the local machine. So it's all in the local node. A mapping process is run now, and there is an intermediary data from this mapper process. I will come and explain to you slowly as to this map and reduce. That's what you will be hearing throughout this meetup, and we will be going through programs which has got both mapper routines and reducing routines in R. That's our goal. Our goal is at the end of this whole meetup, you are really familiar with the mapping process and reducing process and how to write the Mapreduce programs in R so that you could really parallelize your computation and run it using Hadoop infrastructure. Okay. So the intermediary data from the mappers are then shuffled and sorted, and these are really given to what's known as a reducing nodes. So the reducing nodes basically run the reducing processes, and they take this sorted data and merge it and then run the reducing process and then store the output. Again, the output can be local, but it's really in the Hadoop distributed file system. So the name node really thinks it's one file that's come out of this whole reducing process.
Ram?
Yes.
There's a request if you can maximize your PDF screen for everybody. Yeah, John wanted that.
Better?
Yeah, it's just better? Yeah, for everybody. Yeah, thanks, man.
Okay, now mathematically what Mapreduce is all about is there is a map process which takes a key and value and produces a list of different keys and values. So it's a transformation of some key and value to another list of keys and values. And then the reduce process basically takes this key K2 and then the list of all these V2 and then reduces to another list of K3 and V3. So it's basically what it does is it really merges all the K2s, all the keys, and then corresponding lists it takes out and then does a process on them to produce totally a different output, which is what we need. Now this looks very abstract at this stage. Let's just translate this to simple hello world program. In a Mapreduce, hello world is equal to what we call a word count. So let's use a simple word count example here. So let's give word count a text file to this particular program mapper. So mapper gets a file name and a text of all this whole file. Okay. So what we got now, Q1 is a file name, K1 key is a file name, and a value is a text of this file. Then what it does is the mapper really breaks this text into its words and assigns one for against each of these words. In other words, it really creates a big list of words and a one associated with that. So there is supposing you have this mathematically this is as a word, then all the mapper does is mathematically one, this one is one, what one, and so on. So it simply assigns one to each of these words. Then reducer simply sums up all these ones and produces a list of words and their counts. Okay, so this is a very elementary Mapreduce with a word count as an example. We will keep word count right through this discussion only because subsequently we are going to dwell into what's called a sentiment analysis. In sentiment, you are going to take the tweets and going to really compute something what people are saying good and bad, and that's really a word count. Now this is a slide from Yahoo. This is a pretty good slide in terms of explaining the Mapreduce process. Let's say there are 3 sentences I'm putting to the processes. There are 3 map processes. The quick brown fox, the fox ate the mouse, and how now brown cow. Okay, there are 3 sentences. Each one is really fed to the map process. Now the first mapper, what it does is it gets this quick brown fox, so it really breaks set into quick 1, and then the 1, brown 1, fox 1, and gives it to 2 reducing processes. Now, one of the important thing you got to understand in this Hadoop is, what are we really trying to do is keep the data close to these processes. So when Hadoop really runs this mapper, it knows it's got to take this data that's very close to this particular process here. It's got algorithms to really figure out what is the closest data I should really go to, what's the process I should run to go to that data and get that particular mapper run for this against this data. Okay, and then when it's run, it really then it assembles these and then sends it to the reducer. Before sending to the reducer, what it does is it sorts it. So the number of, for example, there is the 1, brown 1, fox 1, the 1, fox 1, the 1, right? So when it sorts, really that gets 1, 1, 1, 1, 4 lists, and that's really given to the reducer. So the sort process basically has 3 these here, and it's given to the reducer. Okay, so one of the thing mapper always does is it guarantees the input to the reducer is always sorted and given. Then the reducer takes that and then sums up all this, and then the reducer in this case is strictly a word count. So it gets how many does here, 3 does here, 2 browns, 2 foxes, and 1 how-tos, and so on. So even the allocation of the reducers to various map inputs is really optimized by Hadoop infrastructure, ensuring that so many reducers are run and the map outputs are really, the sorted outputs are given to these reducers. So this is fundamentally the very principle of the MapReduce process. Now, so far, is it very abstract to you? I mean, you can really, at this stage, you can really ask me a question whether this MapReduce process is very clear to you. Because this MapReduce is all about, the Hadoop really works on this MapReduce as a fundamental paradigm. At this stage, are there any questions?
Ram, actually, there was a question from John. He asked about if the count is done in parallel.
The count is also in that you are talking about the reduce process. Reduce process will also be in parallel typically. It depends on the number of reduce processes that run. So that's also run in parallel. But however, you got to remember that the reducer it starts parallelly ahead even along with the map process. The way it can do that is as soon as I get 1D, it starts saying, okay, let me now put it in the buffer, the 1, this 1, this 1. So this reducer is really in charge of all the T's and B's and F's probably. So the moment all these have arrived, it'll wait for the map processes and it'll simply start accumulating those in the buffer. At the same time, the other reducer also will start counting for the other ones, Q's and A's and C's probably.
Hang on, there's a follow-up question from John. I'm going to unmute him just so he can follow up with this other question. Hang on for a sec. John, you out there if you want to chime in on your follow-up? You're unmuted, John. You out there, John? Oh, he's got a microphone.
Okay.
Yeah,
John,
okay.
just type out. I can see it here. Just
okay,
type it out.
good. Do you want to answer Naveed's question? How does the MapReduce?
Yeah. See, the map process. See, the moment the way the mapper works is something like this. First, it gets these sentences, it puts it in the buffer, and it does the process on the mapper, and then it does the shuffle and sort. The moment the key is sorted, then it knows, okay, there are so many sort keys out there, and I need to really ensure that this particular ones need to be broken into different processes. So the reduce process at this stage, okay, I'm going to allocate these to this reduce processor so that I'm kind of optimum in terms of my my total processing load. So that's algorithm within the Hadoop to ensure that. See, they have several optimization algorithms. The best way, if you want to understand the algorithms on the IO side of it, I would really recommend that Hadoop Definite Guide, Chapter 4. It talks on various IO strategies. These guys really follow. Hadoop guys follow. All the IO strategies are really spelled out there in terms of various algorithms it uses to ensure things are optimal there.
John's follow up with a question asking to define how you close to data in this example, like what that means.
Okay, we are see the closeness to data is there are multiple regional servers, and within that multiple racks, and within the racks you have the data and so on. So when the mapper runs, it's really when the data is distributed, it distributes it to the entire cluster, right? At that point in time, the mapper really got to be working on the data that's really chunk of data that's closer to its node. Basically, that node, whatever data that's associated with that node, and that map process is what it operates on. And that is closeness again is defined. I can really read out their algorithm. Their algorithm goes with some branch tree algorithms by which they really compute. Okay, this is what's closer, and hence this is what it will operate on.
I guess that's it for questions anymore at all. If anyone wants to type them out. Doesn't look like it, Ram.
Okay. But now let's talk about R and Hadoop. That's my area really. What I do is really use a lot of this RMR and from the Revolution Analytics and do the Hadoop programming with R. Hadoop streaming is what is used here in the RMR libraries. Hadoop streaming is basically an alternative to Java Mapreduce. It allows you to write jobs in any language using the standard in, standard out mechanism of that language. So for R, there are several ways you could really work with Hadoop. One is you can write your own mapper.r and reducer.r and run a shell script. I've seen few examples of this, but I don't do that. RMR is what I use really. RMR is a library from Revolution Analytics. You can really download it. It's freely available. The current version is 1.3. One of the things about this RMR library is you need to have this RMR run in each of these nodes, where each of the nodes have to be running R, and each one of them have to run RMR library. RMR library has to be available in each of these nodes. Okay, and Repay is another of the library from Purdue University Statistical Computing. I don't use that much, but that's very well documented compared to RMR. So it's got very similar constructs as RMR. The documentations it's there. In actually compared to RMR, they have documented it pretty well, but I have not used Repay. R-Hive really is Hadoop Hive interaction through R. Again, I'm going to go through Hive demo here, but I won't be using R-Hive. I'll be directly using Hive scripts here. Okay, with that, we will come to the first demo, which is a word count demo. The best way to do that is, let me just pull that program. Okay, so I use library RMR, and I set the backend as a Hadoop because I'm going to have both inputs and outputs from HDFS. And the mapper, so the one of the good structure program here is you define a mapper function in R, and you write a reducer function in R, and then you call out a Mapreduce function. Then you call out your inputs and outputs, and then you take the results and process whatever you want in R. Okay, so mapper function, what it does it takes a key value, which is basically what is input from the stream. For the Hadoop streaming, typically for the input key is none, value is whatever you are giving it. In the case of word count, we are going to give the entire text here as a value. And then the subsequent 3 lines, basically I am cleaning up the data, removing the punctuation, removing the digits, and then turning everything to lower. And then I do an apply function, list up, because we know the whole thing is coming as a list to me, the key value. First, it applies the string split on each of the whole words, and for each of the string split, which is basically the pattern is space there, when the sentence is broken into words, and then I apply a function for each of such lists through the lapply function, where I am really assigning 1 to each of these words. So it emits back to the reducer the word and the number 1 there. Okay. Then reducer, all it does is it says, okay, whatever key I am getting from the mapper, which is basically the word list here, which is what I am returning, and the word becomes a key here, and the list is basically all that ones that are accumulated by the mapper. Okay. By the time it comes here, the words are really sorted, and there is a whole bunch of list of ones there. Okay. Then the reducer basically is saying my output key is key, and my value is, I'm going to unlist all this value list and sum it up, and that's my word count. Then I'm returning through the key val function, the output key and output val. This key val is basically a RMR function that really sends the whole result to the output. And then here is my calling function, Mapreduce function, which basically says this is my Mapreduce, the input is my input I'm going to define, output is the output, basically this is these functions outputs, and input format is text, and my mapper function is mapper.wordCount, this is this function. My reduce function is my reducer.wordCount, which is this function, and I'm going to call now I have defined all my Mapreduce function. This Mapreduce is basically one of these RMR functions here, this Mapreduce. So finally, when I really call this function, I'm saying, okay, give me an output which is going to be in HDFS. Call this MR word count function. This is my input, which is in the HDFS, and this is going to be my output directory in the HDFS. And when I get the results, I'm going to really get it as a data frame and put a column name, word and count, and then simply print out. These are all simple R routines here to print the results. So this is basically the word count program, which is the, okay. For this program, what I have, what I have done here, okay, even before we go executing the program, I'm going to show you 2 screens of my 2 machines which I have in the basement. One is the HD user RAM desktop. That's where the node, that's my main machine where I'll be running my name node, and this is the other node, which is a worker node, which is the XPS. Okay, so the way you start the multi-cluster is I have a Hadoop home variable. So this is first thing I do in a multi-cluster is I have to start the distributed file system. So I start the distributed file system here in my name node. So it started the name node. So the Hadoop model is it's got, okay. So if I look at my Java processes that's running there, that's a name node that's running, there's a data node that's running, and there is a secondary name node that's running in my primary machine. So name node is basically the kind of master that really controls the entire way Hadoop is really Hadoop file system is structured. It's a name node that knows the distributed files across. It's a name node that controls the whole processing, that really controls the jobs. And it's a name node is a kind of master, and the data node is a kind of worker. So it started its worker, data node, because the data node is starting in this particular instance, which is a primary machine here. And there is another one which is called a secondary name node. Secondary name node is a kind of misnomer. It's not a backup of the name node. It's basically there to do some serving work for the name node. Basically, it does the log maintenance and so on, so that when the name node starts, it doesn't take too much time. So secondary name node is a kind of server to the name node. Okay. Now name node is the most critical piece in the Hadoop. If name node machine fails, if there is a complete failure, everything is lost. You just can't recover anything. So it's very important that the name node machine is really the one that really keeps track of the whole thing. So that's the most important one. Now let's go to the other one, which is basically the worker node here. If I look at the process here, it's running data node right now because it's just a worker. So only thing that's running here at this stage is data node. Okay. Now once I started the DFS, my next step is to start Mapreduce task. Mapreduce. Now at this stage, what happens is the moment I'm ready to run Mapreduce, if I look at my processes, I now have, in addition to name node and data node and secondary name node, which I had before, have two other things running. One is a job tracker, which basically tracks all the, which keeps track of the job that's submitted. And then there is a task tracker, which is really done for each of these worker nodes. So when there are two nodes, this is a master as well as a slave. So this slave runs a task tracker as well as a data node. So what would I expect here in the XPS, which is a slave node? I would expect now data node as well as a task tracker. They both will be running. So at this stage, my cluster is ready to accept jobs. So my first job is going to be the word count program. Okay. So if you look at the word count program, before that I run a simple shell script to clean up things. So I'll just show you the shell script. This one basically, my outputs really go to word count.txt, so I'm just deleting that file. And then this is a Hadoop file system shell. So shell command, I can really issue it like this. Remove. This is where I'm really saving my outputs. /app/Hadoop temp outputs word count. So I'm saying remove that directory if it's there, because I keep repeatedly running this. So I'm saying, okay, remove that. Also remove the inputs also directory. And now Hadoop create a directory for me /app/Hadoop/tmp inputs word count. So my word count directory is created. Then I'm copying from local basically. So here I'm copying my WN, basically Wealth of Nation. Adam Smith is a text I'm really using, part 2. So I'm copy that text onto the HDFS. So here I'm copying from a local file system to Hadoop file system. At this stage, the file is distributed across these two nodes, but the name node gives you the illusion to you as an end user that now you got one file out there. But it's Hadoop which manages these chunks in a distributed fashion. So let me run that script. So at this stage, our text has been copied onto onto HDFS. So you can look at it. So it's got that text file. So Hadoop gives you a feeling, the impression that you got one file there. It's called wnpart2.txt, which is really copied onto Hadoop file system. But even though it really appears as one file here, in physical terms, it's really broken into chunks, and it's sitting in some segment of the file is really sitting in the RAM desktop, and a chunk is sitting on the RAM XPS. So it's really split now. So that the Hadoop does several things. One is it ensures there is enough replication. So there is a replication factor which you put it normally in the configuration. So I set the replication to 2, which means even if my data node, one of this RAM XPS goes down, RAM desktop will continue to process the input, because this knows exactly, name node knows exactly how to keep it, so that it's always available, data is always available to it. So the replication is a mechanism by which it ensures the reliability of the data is maintained. Now going to let's now run this R program, R command batch. The program name is word count .r. So it's a batch program. So it's the Hadoop always runs a batch. So I run the usual R command batch word count .r. So it's running in these 2 nodes now. Once it's done, I'm going to show you the R output. So the R out really will show you, so that is a Mapreduce job which is being done. So it really outputs the job output is really available to you in this RAM desktop, the website. So you can really view the job output there, and it's really taken so much time to run the map and reduce process, and the job got completed successfully. That's what it says here. Now if you want to look at the job log here, so this is the output of the Hadoop job. So it's got all successful. It's completed successful. So there are 2 map jobs and 1 reduce jobs, and it gives all the statistics associated with the job, like job counters, all the counters, and it gives the statistics on how many inputs and what are the things it output and so on. So it has really read these 43,000 words and really reduced it to so if you look at the inputs and the outputs, the input is so this is the input file, which is basically an inquiry into the nature and cause of wealth of nations, Adam Smith. The output is really it's a word count of all these words and the number of occurrence within the entire text. So the whole text of 43,000 words has been now counted here. And it gives all the counts of the words. So it's a simple word count program in R to give you an idea of what happens behind the scenes on the Mapreduce with just 2 node cluster. Okay. Now the next example I'm going to show you is it's pretty popular in the literature. This is basically on the sentiment analysis. There's a reason why I took sentiment analysis as an example here is that one is that traders are interested in sentiment analysis. In fact, there's a whole bunch of literature out there on the stock trading and sentiment analysis and how to predict and so on. There are several algorithms out there. In fact, there is an R package called Sentiment is also out there. So one of the things I took is Jeffrey Breen, who's been very active on the R side, RMR and R. He's put a nice tutorial here called Mining Twitter for Consumer Attitude Towards Airlines. I thought I would take the same example. This example unfortunately is not a Mapreduce program. It's a regular R program here by Jeffrey Breen. So you could really go GitHub this and from the GitHub you can get the source code and you can run it as an R program. What I'm doing really is I've taken the same program because it's got so elaborate tutorial here. You could follow the same process in a Mapreduce fashion here. So that's a kind of stand I took. So I took that code and transferred that into a Mapreduce paradigm. Okay. Jeffrey has been very active in the R group in Chicago area, and in fact he's got this here. This one is a very interesting tutorial where he's got similar thing, word count program, as well as there is an airline. He's got 2 examples here. Yeah, this is a very interesting example again. If you get time, you could play around with this too. I got the source code for this also, but I won't be running this. But this is about airline arrival departure delay analysis. This delay analysis is pretty interesting because it's about 8 million records. With 2 clusters, I could really process it in about 10 minutes time. These 8 million records, and it really gives you the airlines that's been consistently delaying and so on. So this is a very interesting example as well. So you could run through that. But currently what I am going to do, because it's a trading thing, I'm going to be running this airline sentiment analysis, same program, but now I'll be running it through a Mapreduce thing. I'm going to show you this program first. So the code is very similar to what we have seen as a word count program. So it uses RMR and it uses PyR for some of these word matching, I think. And then it uses string R. Now what it does, and let's understand the simple scoring mechanism. The way he does it is there is a set of positive words and the set of negative words he's got out of Hugh and Liu their research work, and it's got lexicon of positive words and negative words. To that lexicon, Jeffrey adds few other words like upgrade, waiting, and all that stuff. So you could also do that if you are doing your own sentiment analysis on stocks. You could add to your lexicon So you basically create your lexicon of positive and negative words. Then he's got an algorithm. This algorithm is fairly simple. All you pass there is a sentence, a positive word and a negative word, and it basically computes, it matches from the sentence, it matches the words for positive words and negative words, and it computes a score as sum of positive matches minus sum of negative matches. So it's simple algorithm for scoring the sentiment. So let's look at the mapper function here. Mapper function, all it does is I take the entire tweets. Even before that, I got to show you how the tweets are really obtained. So what I do for the tweet side is, let me just get out of this here. So I use the library that's used is Twitter basically. So that's our library that's available, and what it does is it searches the tweets and gets you up to number of tweets. Typically 1500 is the maximum I think they give of all this freebies here, free tweets. So what we do is we put the counter as a 1500 here, and then for each of these airlines, let's say airlines AA, I've written my own routine here, which basically searches the tweets and then gets all those tweets with American Air as a text anywhere in the tweet, and then what I do is I tag AA to the tweet so that I can do meaningful analysis. I know this Twitter is about AA. Later on when I go and search for a positive and negative words, I know I can use this AA. So I tag it. So this routine tags AA, DL, JB, SW, US Airways and United and so on. So all the six, I collect 1500 tweets from each of these airlines, and that's what this program, this routine does. So then let's get back to our, then the shell script basically, while all it does is it, so this shell script basically, it runs the scraping routine from the tweets, and then I write out separate tweets for American Airlines, Delta and so on. So all these tweets are written out. Okay. Now at this stage I'm ready to run my Mapreduce program. My Mapreduce program would basically, the mapper would take the key value, which is basically the CSV file. So this CSV file would be taken, and then it would parse that CSV file, and then it will assign I tag the AA or DL as the first two characters of the tweet. So I take that as a key, and then output key, what I do is I do the scoring of this tweet with the positive and negative words. So what I get for each tweet is that airline as a key and its score as a value. Okay, so it's very similar to the word count program. The word and the one, instead of that, I really put the key as an airline and scoring the sentiment score as the value. Okay, so sorry, I don't do that, because what I'm really interested in doing is counting the scores. So I keep the key as both the airline and the score as a key, and I output the value as 1, so that I can really count the airline and the corresponding score as an output. Okay, so my reduce function is simply a sum of, for the key is same as the key here is airline plus sentiment score, and my output is sum of all those scores. Okay, so I do the same thing like my word count. I print it out, and if I run this program now, so I have a similar to the previous word count. There is a shell script I have, which basically deletes all these outputs and deletes the files to the outputs and the inputs, and then copy from the local all the CSVs, which are about 6 CSVs, one for each airline. I'm copying it to the inputs here. Then I run very similar to previous word count example. I run this program. I think I done some mistake here. Sorry. So it's, the batch is getting run now. Yeah. Now we look at the output. Basically, it gives the airline and a score and a corresponding count. If you look at it, people haven't scored anything. It's for AA at 0 level, and at negative level, American Airlines has got 270 guys who really said it's at least one complaint, and 66 at 2 complaints, and so on under each of these tweets. So this is basically gives you this for each airline and the score and the counts. Okay. Similar to our this thing, you can also look at the R out. So it basically it shows the job being done as a Mapreduce, and you can view the job and task outputs here. This URL. Okay. So this is my second example, because from the word count, extending the same word count program into airline sentiment analysis, and you could really go through Jeffrey Breen's elaborate write-up on the tutorials there. So you could use my program to run your basement machines and correlate that to Jeffrey's tutorial there. Okay. My third demo is going to be on the Hive. So far we have seen the R side of it, how to write a MapReduce in R. Hadoop also has got a facility which is very SQL-like mechanism called Hive. So Hive, so I'm basically again a shell script here. I'm running a I'm deleting my files from the stock. Here what I do is I run a stock scraping program, which is basically so if you remember the introduction to R, similar to, so what we do is we, from the URL Yahoo Finance, I get the GE stocks and read it as a CSV, and then write it as a data frame, and then finally write out the text file as ge.text. So my ge.text looks like this. So it's basically got all the GE date, opening, closing, and high, low, volume, and finally the adjusted closing and the symbol. Okay. So what I do in my Hive example, I'm loading this program into this data, GE stock data, into HDFS, and then I'm creating a table in Hive, and then actually first I'm creating a table in Hive, then copying from the local data, and then I'm doing a Hive query. Okay, I'm going to show you each of these scripts. So create table, basically it looks very similar to our normal SQL. So you drop table stocks, and because I had these stocks created, so then create an external table stocks, trade date, open, high, low, close, volume, adjusted close, stock symbol. Row format is delimited by comma, because it's a CSV file, lines terminated by new line, stored as text file. The location is where I copied my, where I'm going to copy my local file. This is a this is a HDFS location. Then on the query, well, all I got to do is from stock, select this where stock is greater than, whatever you can do, any kind of query here, right? So we don't need to do a query here because there is a separate query there. Okay. So that's basically all it does. It does a create table, basically does that, and then the query does from stock, select stock, trade, open, high, low, where stock close is greater than 160. When was General Electric greater than 160 bucks? If you remember, it's probably in the .com days. So anyway, let's run this Hive example. So it's running. If you notice, you'll notice something here peculiar. As it's running, it's really behind the scene, it's running a Mapreduce tasks. So this first Hive, basically create table, is run as a map only task with no reducer. Similarly, the query also is run like a map only job, and it's really behind the scene. It runs a Mapreduce thing, and it produces this output, which is basically all the GE stocks where it's greater than 160 closing. Yeah. So that's my third example. So let's go back to our. Okay, so we covered the sentiment analysis, then we covered this Hive example. Hive is a data warehousing infrastructure for Hadoop. It provides very familiar SQL-like interface to create tables, insert query data, and behind the scene really implements Mapreduce. Hive is an alternative to our Hadoop streaming we covered before. So what we did here is the stock query with Hive. Okay. So what are the use cases for us traders? Stock sentiment analysis is one thing that's frequently used. Stock trading pattern analysis, I've seen literature, at least if you look at this directory of if you go through the Hadoop wiki, it lists out all the companies which use Mapreduce. I've seen few companies using stock sentiment analysis. That's why I listed that out there. Sorry, the stock trading pattern analysis. That's listed as one of the applications they are using it for. One of the companies which basically analyzes stocks. And they could also, I've also seen mention of default prediction using Hadoop. Fraud detection, it's pretty much used, and there are some big firms trying to use Hadoop for fraud detection nowadays. And then, as I said, Hadoop Hive is also used as a next generation data warehousing. So these are the typical use cases I've come across for Hadoop within our trading realm. So the Cloudera is the one I use. Cloudera distribution of Hadoop is one of the most popular distribution. I use CDH3 V5, I think, in my 2 demos above. It's very simple to install. All you got to do is just change your sources list to include Cloudera location, and then simply do like a normal sudo apt get install and you install the Hadoop. So it's fairly very straightforward installation using Cloudera distribution. Doug Cutting is the creator of Hadoop, is the architect with Cloudera. Adam Muse is a Cloudera engineer here in Toronto. Unfortunately, he was supposed to attend today. He couldn't attend actually. He is also organizer for the Toronto Hadoop user group 2Hug. That's been pretty active actually. They conducted one on, in biosequencing areas, Hadoop is pretty much used actually. So he conducted one on how Hadoop is being used in biosequencing applications. There's one that's coming up on the 30th October. It's about Pig. Pig is another tool very similar to Hive, but it uses different language called a Pig Latin. Pig Latin is used as a kind of workflow language, and you could use Pig as a tool for Hadoop queries and so on, particularly on the workflow side. So he's going to conduct one on the Pig Fest on the 30th October. In fact, I really don't know much on the Pig side, so if you are interested in learning Pig, I think that's probably the place to be in. Okay. So 2Hug also is in the meetup groups. I think you can go through the meetup groups too, for the Toronto Hadoop user group. Okay, and Hadoop tutorials on books. Apache's Quick Start is probably the first place to start. Cloudera has got a university, and they have various videos put out there, nice videos. Of course, the training is kind of a bit expensive, about $2,000 I think for each of these courses, but they do conduct training. Hadoop in Action is a kind of overview book. It's not a very detailed book, but if you really want to get into detail, like the kind of questions you had asked about the I/O, about the optimization and so on, this is the book. This is by Tom White, which is basically he was in the Hadoop team. Even now he's in the Hadoop team. So the Hadoop, the definitive guide is probably the best book you could get out there on the Hadoop. And the Hadoop streaming, Apache has got several tutorials. This particular one talks about Hadoop streaming, and Google Code University has got some Mapreduce tutorial. By the way, Google is moving away from the Mapreduce paradigm, but they still have these Google Files system, and they are the ones who really introduced Mapreduce to the world. And Yahoo's got a nice tutorial under Yahoo Developer tutorials. So that's by and large what what I have to talk on the R and Hadoop. Basically, it's about the RMR library and how do you really write Mapreduce program in R. Back to you, Brian.
Wow, thanks a lot. That was quite awesome. As usual, I got, if you guys got questions, if you want to type them in the chat mode, just type away. I'm hoping we'll have a bunch. That was really good, Ram. I'm just right now, obviously, I've been playing with the Redis, totally different from Hadoop. I haven't played with Hadoop myself in this context, but with Redis and R, you can use it for parallelization and use it as another map system. Question I had for you, Ram, is let's say if one of those workers dies, especially if it's part of the file system, what happens in that mode? I mean, is there another way that data automatically gets transferred over to another worker? Or how does that work?
See, the Hadoop, the name node manages everything. It's a name node which really is responsible for allocating your input data to various nodes. So from the user point of view, it's really transparent. And it also ensures the replication so that if there is a failure, it automatically switches to the other nodes and so on. So I have, for example, I have had failures within my 3-4 machines. Once I plug out one of them, the Hadoop continues to run as if it's really transparent. It thinks, okay, I can now manage. That's out now. The data is out. That node is out. However, I know I have replicated here. I will go and get that out of that. So from the user standpoint of view, you really don't care. Name node manages everything.
So you won't lose any data on any of the nodes, because I thought with that node that node stores the physical data, but I guess it somehow manages it from the master node, right?
Yeah, it replicates everything. It replicates both the data as well as it replicates the processes. So it knows, okay, this is how now I got to work around given that node has failed. Yeah.
Okay. We got a question from Misha about, I'm just going to put it out there, just speak it out so the people watching the recording can get it. So thank you, Ram. It's from Misha. Can you compare Hadoop and GPU architecture? I understand they can be used together, but can you give us some speed comparisons?
Sorry, I think that's too technical for me. My background is more like application guy. I'm an application guy, not so much of infrastructure and architecture and so on. But ideally, what you should do, Misha, is if you could really, I would answer this anyway. I would get the answer and send it across to you. It's not a problem for me.
Well, I could probably go ahead. Ram.
Cloudera guys are the best guys to answer such questions on the speed comparison and so on, because Cloudera guys really have good benchmarks and all this stuff. I would really talk to Adam and get some answers for you.
I can say about this with Misha, or for Misha, the difference between Hadoop and GPU are totally different type of applications. You got to remember that Hadoop has a file system. All the GPU architectures are in memory, which obviously there's no file system. So a good comparison is what I've just recently come across was the difference between an Oracle relationship, database management system where everything's on a data store, while if you use something like what I've been using, a times 10, which is basically an in-memory database. So they're two totally different things. It's like comparing an apple versus an orange.
See, this is purely batch with very high latency. You cannot compare this. See, here we are not talking about small volume of data. Here is a huge data. Here we are talking about, say, millions of tweets that are coming in. That's huge I/O bound here. That's where Hadoop really excels. Hadoop doesn't excel in your real-time in-chunk point or 20 millisecond kind of response. It cannot give you that. Yeah. Even as I ran this, you probably very clear, even this small text file, it takes so much time to come out with a two-node thing.
Okay, it looks like we've answered Misha's question. Any other questions at all? Just type them in the chat. Anybody at all?
So your Redis is really ideal for in-memory analytics. Hadoop really doesn't do very well there.
Yeah, that's right. For anybody who wants to know about Redis, I've done a demo for my premium membership that's available within the membership. It's a full-on hour demo where I've got 3 workers, very similar to what Ram set up with Redis. If you want to see that in action, just give me a sec. I can pull it up if you're interested. Or if anyone's interested, just type it away and I can get back to you on that. It's quite ingenious how Redis architected it. Anybody else got any questions at all? Anybody? Type away. I got to thank you very much, Ram. I mean, you've put a lot of work into these as usual. It takes a bit of time from, I know. Yeah, so Jiang, I'm sorry if I pronounced that wrong, has got Twitter Storm. Ram, if you can answer that.
I've not used Twitter Storm. I only use this Twitter package. I've not used it.
Yeah, I'm just doing a current search on it. Hang on, Jiang. Just give me a second here. Yeah, apparently it's part of a Hadoop package for Twitter. It's called Storm. Yeah, it's part of something to do with part of Hadoop. But I guess none of us have actually used it, Jiang. Sorry about that. Anybody else got any other questions? Go ahead, type away. This is your chance. Anybody? I guess that might be a wrap then. Anybody got any questions? We'll do it going once, twice, 3 times. Anybody want to say thanks to Ram for all his work? Just type away. Just give him the acknowledgement for all the work that he's done. Yeah, there you go. There you go. Yeah.
Thanks.
Yeah, because he's done a lot of work. This is his second presentation. Thanks for saying thanks. I appreciate that. Yeah, so where do we go from here? Anybody else got any questions before we get on to the next set of meetups that we got coming up? I guess not. The next set of meetups, we're going to be focusing more on the strategies development within R. I'm going to be probably building a full-on HFT platform over the probably next month. So I'll be doing some meetups on that. And also trying to pull in some big wigs. I'm going to see if I can get Revolutionary Analytics in to do a presentation on their solution of their server of the R, as well as I'm going to try to get Ernie Chan as well, and some other big people as well. So this is what I'm trying to line up for November and December. Anybody else got any other questions at all before we give it a wrap? Just after 8 right now. We'll do a good one once again. Ram, awesome presentation. I'm going to put this up on YouTube as well for everybody so that we can get this out in the public domain.
Thanks, Brian.
Lots of hard work. Hopefully anybody can come out to our next meetup in North York a week tonight. North York, Ontario, Canada. Come on out. Just confirm for me for the reservation of the restaurant, and we'll continue the story there. Anybody got any questions? We'll do a going once, twice, and we'll give it a wrap. So I will do it right now. Going once. Any questions? Type them up. Going twice. Going 3 times. I think that's a wrap for everybody. I appreciate everybody coming out tonight, especially you, Ram, for doing this presentation. Again, another great presentation. And everybody, thank you very much for attending. We'll call that a night. And again, hopefully we'll see you online in a future meetup in the next week or 2. All right, Ram.
Thanks. Thanks.
Have a good night. Take it easy, man. Later. Bye all.